In this video, we're going to talk about how to analyze the units in a definite integral expression. I have several examples. The first two I'll explain to you, and then in the next two, I hope you'll pause the video and try to figure out the units for yourself. Here's our first example. We've got a car traveling on a straight road, and this graph is showing us the velocity, v of t, in meters per second. We're asked to explain the meaning of this definite integral. And one of the ways to figure out the meaning of a definite integral is to attach units to the different parts. So the velocity here is measured in meters per second. So meters per second. And then you need to remember that this differential here carries units as well. It's time, and the time in this problem is being measured in seconds. If you multiply these seconds will divide out, and so our final answer is going to be in meters. This is an example of how we analyze the units in a definite integral expression. Here comes our next example. In this example, we have the temperature of a wire that's being heated, and the temperature is measured in degrees Celsius, and the temperature varies along the length of the wire. X represents the number of centimeters from the heated end. So here we're asked to find the value of a definite integral and indicate units of measure. So what I would like to do is attach units to the various parts. You need to notice that the integrand is a derivative. That means it's a rate. And so the units for t prime of x would be degrees Celsius per centimeters. Degrees Celsius per centimeter. And then I know that this differential x is being measured in centimeters. These centimeters will divide out so that my final answer will be in degrees Celsius. Here comes our next example. I'm going to put this up, and if you would like to take a moment to read this problem and then pause the video, you can try to figure out the units for this integral expression. And knowing the units might help us to determine the meaning of the integral expression. Go ahead and pause now and see if you can figure out the correct units. Okay, we're back again. We're trying to determine the units for this particular definite integral expression. When you look at this, you might notice that b of x represents the diameter, and then if you divide a diameter by 2, what you're getting here is a radius. And a lot of students notice the pi radius squared, and they think, oh wow, I know what that is. It's the area of a circle. And so they think that this is going to be an area. Well, that's where you're getting tricked. Right here, this radius is going to be measured in millimeters, and we're going to square that. But then remember too that this x value also carries units. So x is measured in millimeters as well. When I multiply my millimeters squared times my millimeters, my answer is going to be cubic millimeters. That's interesting because that indicates that this answer represents a volume. Specifically, it's the volume of blood measured in cubic millimeters in this blood vessel between 125 and 275 millimeters. I've got one more example, but in this next example we have two different definite integrals that we'll try to interpret. Okay, so here we've got some information given. R of t represents the rate of fuel consumption, and that's measured in gallons per minute. And then we're going to determine the units for these two definite integral expressions. Again, you might want to pause the video here, see if you can determine the correct units, and then restart the video to see if you're correct. Okay, welcome back. We've got two definite integrals to interpret. In this first one, integral from 0 to b of r of t dt, r of t, we learned earlier, carries units of gallons per minute. Whereas this differential is our time measurement, and that's done in minutes. The minutes will divide out so that our final answer for this definite integral will be something that's measured in gallons. Is that what you got? Let's look at our other definite integral. Over here, this one is quite a bit trickier. Most people notice that r of t is measured in gallons per minute. They might also notice that you have the differential that's measured in minutes. The part that a lot of people forget, though, is this portion right over here. This coefficient also carries units. 1 over b, and b is measured in minutes. It says so right here. Notice that this time, these minutes divide out, but we still have units of gallons per minute. That means that my answer must be some kind of a rate. Specifically, it's the average rate of fuel consumption for the plane. So, gallons per minute. I hope that this video has given you some idea of how important the units are in a definite integral problem. They often help us to determine the meaning of the definite integral that we've been given. Thanks for listening, and remember to always enjoy calculus.